Okay, 7.3b. Still drawing similar polygons, but this time we are going to be using the ratio and parallel methods instead of a ruler and protractor. Okay, so we're just going to be using either graph paper like we are for this example, or looking at what the ratio and parallel method are for drawing similar shapes. Okay, so example 4, we are going to be using graph paper. Using graph paper, construct a figure that is similar to one given with sides that are 1.5 times the length of the original. So first off, let's take a look at what our original side lengths are. So here, this is 4 squares. So 1, 2, 3, 4, 5, 6 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 squares. Okay. Now this goes down 1, 2, 3, 4 diagonals. Okay, and here we have 10 diagonals. So let's take these, just going to put all these on the outside, and figure out what it's going to be if we do something that is 1.5 times as big. So 1.5 times the length of the original means it's going to be 1.5 times larger. So 4 times 1.5, and we get 6. 10 times 1.5, we get 15. 18 times 1.5, we get 27. 6 times 1.5, we get 9. And then 4 times 1.5, we've already done 6. Okay, so we're going to be making this lower, and we're going to put this corner right here, right in the corner here, to make sure that we have enough room just in case. Now, what I would like you to do is use a ruler. Okay, so you should be using a ruler for drawing this. Even though you have graph paper, you want it to be nice and straight. And I will be able to tell if you are not using a ruler for your lines. None of you are that good at drawing straight lines. See, look at how messy that looks. Horrible. Okay, so starting off, we need to go not 6 up, but 9 squares up. So starting at the bottom, we want to go 9 squares up. So 1, 2, 3. 4, 5, 6, 7, 8, 9. Looks good. Okay, and then we need to go straight across diagonally for 6 squares. So instead of 4 squares, we are going to go 6 squares. We could also double check by looking at this angle, but if this one's straight up and down and this one's going straight across, we know that it's going to be okay. So 6 squares over across like so. So lining this up. Oh, I think it'll be okay. We'll see. So 1, 2, 3, 4, 5, 6. Okay, then straight across, we need to go another 6 squares. So that was 4, 1.5 times bigger, 6. So 1, 2, 3, 4, 5, 6. Okay, then diagonal again for 15 squares, or we can count the bottom 27. It really doesn't matter, but since we know we should be going diagonally till we get to the bottom, since we started at the bottom, we can just double check and make sure when we get to the bottom we've gone 15 squares. So like so. And diagonally. Can't do this, but I can make my ruler longer. Here we go. Right. So let's see if that worked out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Darn you, limited mode. Okay, so that worked out fine. And lastly, we just have to draw our, what is it, 28? 27 across the bottom. Okay, and we could check that, but I'm going to assume since everything else was okay, that will also be all right. But it is a good check. So here we have 6, 6, 9, 15, and 27. Okay, so that's using grid paper. So it works out nicely. Just make sure you use a ruler. I know you have the grid, use a ruler. Next, the ratio method. So we use the ratio method if we're creating a reduction. So the ratio method gets used if we're making something smaller. And the steps are these. So we choose a point that's external. So external just means outside the shape. And the point will become the center of reduction. You might have seen something like this if you have done 1-point perspectives in art class. So this is exactly what you would do to make a vanishing point. Okay, so making a vanishing point in art class. That's what we are doing here, except mathematically. So next we're going to choose a scale factor to reduce the image. For this image, we're going to scale it down by a half. So we want to make it half as big. What we do is we take each of our vertices and connect them to this dot. So usually you want a small dot. This dot's actually quite big. Go. But we are going to draw lines. So straight lines from each vertex of our shape to that dot. So there's our first line, and even vertices over here. Okay, so here's our second vertex. There. Third vertex. Oh, that gets in the way. Okay, our fourth one up here. So let's do this vertex, stop there, and our last one. Okay, next what we need to do is find the midpoint of each line. All right, so taking a look here, our midpoint. So yours is probably going to be different because I don't have this exactly, this ruler is not exactly to scale to what it is. So this is going to be different from what you actually have. So for mine, this goes from 0 to about 12.6. Okay, so the middle of 0 to 12.6 is going to be half of 12.6. So 6.3. So 6.3 is right there. Oh, and I'm not going to be able to draw it. There we go. Okay, so there's my dot, my midpoint dot. Taking a look at the next line. So you have to, if this line doesn't end here, this line ends all the way over here. Okay, so all the way over here, it looks like, for me, anyways, it's 17.123-ish. So 17.3. Oops. So half of 17.3 is going to be about 8.65, so like 8.7-ish. So for this line, 8.567, there's my midpoint. Okay. Remember this one was 12.6. Show my work. You won't necessarily have to. I'll just show you what I'm doing here. So 12.6 divided by 2 gave us 6.3. Okay, this one over here, we have about 10.123, about 10.3. So 10.3 divided by 2, we get 5.15. So like 5.2-ish. So 5.1 and then 5, like halfway between. There we go. for that line. All right, this line is, remember, don't stop here. You have to go all the way to the vertex. Okay, so 15.6-ish. So 15.6 divided by 2, so cut that in half and we get 7.8. So 7.5678 right there. Very good dot. And last one. Okay, so from 0 to like 11.4. So 11.4 divided by 2, and we get 5.7. So 5.567. But once again, your scale on your drawing might be a little bit different. So make sure you're actually measuring for you. So it might not be these for you. Okay, so now we have these dots. So I should have as many dots as I have vertices. If I don't, that means I missed a line. Okay. So our next step is 1, 2, 3, 4, 5 dots, 1, 2, 3, 4, 5 vertices, is to connect the lines. Right. So here's our first one. Here. Taking our ruler, making sure you are using your ruler. Here. Between our next two. Here we go. Oops. These two. And lastly, taking my ruler over and connecting these ones. Oh, trying to make yours not as hideous as mine. Great. Oh, that's horrible. Racing it. Racing you line. Okay, that's a bit better. Yeah. Okay. There. Now it's kind of up to you. You can outline this one in like pen or something, and then you can erase your lines, but it's not really that necessary. But this figure is going to be half as big as this one, and we could check it. So let's take a look at a couple sides. Ay, caramba. Go back. So let's take a look at this bottom side. So it's about 6.4-ish. So this should be about 3.2, which it is. Okay. So all of our sides should be half as big. Our angles should be the same. Okay. So take a moment to do this one. So remember, first step is drawing your lines. Right? So draw a line from each vertex to your dot. Okay, we're going to cut those lines in half. So cut the lines in half. So half of each line. And lastly, connect the dots. Okay, so there, creating a similar pentagon that's half the size. It's been cut in half. These should be half the size. So if I take a look, let's just do a quick check. On mine, this is 6 centimeters, and this is 3. Okay, so perfectly half the size. Great, I'm done. Okay, so this is our ratio method. So ratio, think smaller. Okay, so just how the ratio method was to create a figure that is smaller, the parallel method is for enlarging a figure. So this is when we want to make a bigger figure. So when we want to make a bigger drawing, but still have it similar without using a protractor again. So the only thing you need is a ruler for this. So choose a point that's inside of the shape you want to enlarge. So the ratio method, you chose a point that was outside. Here, you're choosing a point that's inside of the shape that you want to enlarge. And it does not need to be in the center of the shape at all. So that point will be the center of enlargement. Next, kind of same thing. You're going to draw rays connecting that point to each vertex in the shape, and you're going to extend the lines this time. And we're going to use this method to enlarge the shape by a scale factor of 2. So we want to make it twice as big. We're going to measure the distance from the center of enlargement to each vertex, and then we are going to double that length. We're going to mark a point, and we are going to connect them. So similar to the ratio method, but just with some key differences. Here our point is going to be inside, and instead of having it, we are making it bigger, so doubling it. All right, so from our point here to this vertex there. Okay, and not quite in the center of my point. This point is too big. Try to make your point smaller. It's just horrible. All right, so this is, if I take a look, I drew something that was from 0 to 2.567. Right. So what I can do now is, instead of just drawing my rays out a bunch, I can actually measure while I'm doing this how much farther it needs to go. So I measured to 2.7. So 2.7, and I'm going to be doubling this. So 2.7 times 2, and we get 5.4. Okay, so I need this line to extend to 5.4. So we're just kind of cutting out some steps here, making it a bit easier for ourselves. Okay, next we're going to go to our next vertices. Oh, going weird. There we go. That's what I want. Okay. That's better. All right. So from 0, this one is about 2.12, I guess, to the 3. So 2.3 times 2, we get 4.6. So this line needs to go out all the way to 4.56. There. Okay. Next, the next vertices. So this goes, that's off a bit. From 0 to about 2.1. So 2.1 times 2, and we get 4.2. So this line has to go all the way out to 4.12. And last line. So from 0 to here. So 0 to 2.5. So 2.5 times 2, and we get 5. So this one has to go all the way to 5. Okay, now this way, since we didn't have our lines extended any more than they needed to be, we can just connect the very ends of our lines together. So here we go. Did not have that lined up. Very good. There we go. Here. Oh, wow, that was really off. Sorry. There we go. And right here. There. Okay. So even though it wasn't quite in the center of the shape, notice how our 2.7, 2.3, 2.1, 2.5, it was at like it was longer to reach each of our vertices. This should still be twice as big. All right, so taking a look, let's just do a quick check. And we get, actually this one's a little bit nicer to measure. So 8.4. So this is 8.4. So our smaller one should have been 4.2. So taking a look, 4.2. Yes, we're good. Okay, so this should be okay. This should be twice as big. Oops, so 2 times bigger. Okay, now your turn. So same thing, use the parallel method to create a similar pentagon that is double in size. So pentagon, 5-sided figure. So 1, 2, 3, 4, 5 sides. So first off, draw your lines out and measure how far they are from that point, and then double that. So lines are doubled through each vertex. And lastly, connect the ends of the lines to get a figure that is twice as big, so double the size. If I asked you to triple the size, instead of multiplying each of your lengths to your vertices by 2, you would just do it by 3. Okay, so it can be 3 times as big. Okay, but here, just doubling the size. Right, and you can go on to your assignment 7.3, ratio and parallel method. So you will have one to use a graph with. Make sure you use a ruler. You will be using the ratio method to make something smaller, and you will be using the parallel method to make something bigger. All right.